Okay, so our notes today, ladies and gentlemen, are going to pick up from where we left off in class a little bit. I'm going to review what we did in class today and also try to extend a little bit on what we were talking about with picking a plan of attack on how to solve a problem. All right? We're going to take a look at this problem having to do with a soccer ball being kicked horizontally off a 22-meter high hill. And when we're done, the idea will be is that maybe tomorrow when you come in, and actually tomorrow when you come in, you should have a better idea on how to set up the steps for solving a problem. Now, every problem is going to look a little bit different, so the idea is not to copy down necessarily what I do and do that for every problem in the future, but just take away what are the steps that he took, how did he make his decisions, and can I think in those terms as well? Can I make decisions being a critical thinker and based on my knowledge of these kinematics equations and the situation? So let's go ahead and start off with the problem. A soccer ball is kicked horizontally off of a 22-meter high hill with an initial velocity of 16.67 meters per second. Determine the distance, or determine the time it takes the ball to hit the ground and the distance it travels away from the base of the hill. Alright, so let's go ahead and set up the problem. Here's my hill, here's the soccer ball. The soccer ball is going to be kicked off of the hill horizontally and land on the ground. Now the hill itself is 22 meters from the ground, and the velocity at which the soccer ball was kicked is 16.67 meters per second. Alright, so let's see. The time that it takes it to hit the ground, that's a question mark. Now time is a funny variable because the time doesn't depend on vertical or horizontal. It just is. So time doesn't follow the same rules as vertical and horizontal. It's just the way it is. So time is really kind of a shared variable between our horizontal and vertical variables. Alright, so I'm going to change this question a little bit because from the base of the hill is going to be a little tough because I don't know how far the soccer ball was from the base of the hill when I kicked it. So I'm going to change this to from where it was kicked. So let's determine the distance it travels away from where it was kicked. Alright, so we can go ahead and set that up on our table as well. So basically we're trying to figure out this right here, which is where does it land from where was it kicked. Alright, so let's set up our variables, and first we're going to identify what's going on here. So there's a vertical component and there is a horizontal component. And actually I said those backwards. So a horizontal component across and a vertical component down. Alright, so let's set up our variables, vertical and horizontal variables. Alright, so vertically and horizontally we have to take into account acceleration and time, initial velocities, final velocities, initial positions, and final positions. Alright, so let's fill in the ones that we know. Okay, vertically, we know that the acceleration due to gravity is negative 10 meters per second squared. The negative is because it's working downwards. Horizontally, acceleration due to gravity has no effect. And so we're going to say that there's zero acceleration horizontally. So the time is a question mark. We established that already. Vertically, we'll say that the initial velocity is 0 meters per second. Now the reasoning behind this is that you'll notice that the soccer ball is already at apogee. Apogee is a vertical word, basically. It has to do with how vertical something is. So if the soccer ball is already at apogee, then anything that's at apogee has a vertical initial velocity of 0. The initial velocity horizontally is 16.67 meters per second. I kicked the ball off of the hill with that horizontal velocity. As far as the vertical final velocity, we don't have any clue about that. We don't know if we just drop the ball from that height, how fast it would hit the ground, basically. We don't know that. We do know that the horizontal final velocity is going to be 16.67 meters per second because we have a zero acceleration horizontally. And there's two things that can happen when we have zero acceleration. One is that the object isn't moving, or two, it's moving at a constant speed. So we know it's moving, so we have to assume that it's moving at a constant speed. And so whatever the initial velocity is, that's what the final velocity is going to be for the horizontal movement. The best way to think about the horizontal movement of an object is to imagine what would it do in space where there's no gravity and there's no air resistance to slow it down. Alright, for the vertical initial position, we'll say it's 22 meters because that's where it started vertically. And then we'll say that if we were to just drop it off of that 22 meter height, it would hit the ground at 0 meters. Horizontally, we'll say that the initial position is 0, and I'll add that to my graph, or my picture. So 0 meters, and we're looking at the horizontal, and we don't know where it's going to land. So initially we'll say it's at 0 meters and we don't know where it's going to land. Alright, so this is what we accomplished in class. So hopefully this is just a good review, and what we're going to do now is we're going to examine what exactly we do with this information. So how are we going to set up our problem? Alright, so let's go ahead and take a look at our information. Alright, so let me move this stuff over to the side here. And we'll add a line. And what we're going to do now is come up with the steps for solving for these question marks. So what I'm thinking is the problem is asking for two things. It's asking for time and it's asking for where does it land. So the horizontal final position. So I'm going to start making a list of things that I need to find. So I do need to find final position. Alright, so what is the horizontal final position? That's a question mark for me. So I'm going to take a look at the equations that allow me to find final position. And we're looking at the horizontal final position. Alright, so check out the equations above my information, and I'm going to put some yellow stars. These are the equations I can use. Here's the problem. All of those equations that I just starred to find final position require time, and I don't know what time is. So it seems like before I can even figure out where did the ball land, I'm going to have to figure out the time it took for it to land, because almost all of the equations require that I have time. Okay, so I have time that I have to find then. I'm missing time from both the horizontal and the vertical, but that's the same time. Alright, so let me take a look at all the equations that allow me to find time. Okay, not that one because it doesn't have time. I can't use that one because I don't have a final velocity. Well, I do have a final velocity horizontally, but what you guys will notice is that those two the initial velocity and the final velocity horizontally just cancel each other out in that equation. I can't use that equation. I can't use this equation because I need final velocity, and again, those two would just cancel each other out. And I don't know what XF is, and I can't use this one because I don't know what XF is, and I can't use this one because I don't know what XF is. Well, maybe I could, but the problem is I don't want to find XF, I want to find time. I guess I could use the vertical XF, but again, like, I look at that and it's like, how am I going to isolate time in that equation? That seems impossible. Alright, so I'm left to looking on the wall, and on the wall we have this triangle which says final velocity minus initial velocity divided by acceleration equals time. Here's the problem. I still need final velocity. And if I take my horizontal final velocity and subtract it from my initial final velocity, I'm just going to get 0, and that's not going to help me solve for time because it'll just say 0 seconds. So time seems to be a big, I don't know, black hole for me. So I don't know that I can find time right away. So I'm left with looking at, well, what do I need to solve for? If I can't solve for final position and I can't solve for time, then it seems like I have one more question mark, and that's my vertical final velocity. So let's go ahead and see what we can do with that. Alright, and that's my vertical final velocity. I'll put a little arrow there to identify vertical, and then my horizontal line there. Alright, so I'm stuck with how can I figure out what the vertical final velocity is? Alright, so what equations will help me do that? Well, there are two kinematics equations that will help me find vertical final velocity, and that's alright, and let me rearrange here actually. So it seems like I need to find things in this order. What is the vertical final velocity? What is the time? And then can I solve for this? So maybe if I know what this one is, I can solve for that one. If I know what that one is, I can solve for the last one. Alright? Alright, so if I know what this is, I can solve for that. If I know what that is, I can solve for the final position. Alright, cool. So let's look at the equations that will allow us to find final velocity. And so I'm going to start listing my steps here. So step number 1, I think I need to find final velocity vertically. Okay, so the equations that can help me do that is this one, Vf equals At plus Vi, or this one. Here's the problem. I can't use this equation because it requires time, and I don't have time. So I'm stuck with using this equation right here. And I actually can use this equation because I know all of this information. I know what the vertical initial velocity is, I know what the acceleration of gravity is, and I know the distance that it's going to fall to the ground. All of those will help me solve for the final velocity vertically. Awesome. Alright, so once I know what that is, then I'm going to try to figure out what time is. So find time. And I know that I need to use this equation right here. Well, this is awesome because now I can actually use this equation. I can take my vertical, all my vertical information, and I can plug it in here. If I find what the vertical final velocity is, then I can use it in this equation with the initial velocity and the acceleration of gravity to figure out how much time it would take to drop to the ground. So this time will let me know time to hit ground. Awesome. And I can find that because I know what the final velocity is vertically. Alright, third step. I am going to find xf. Alright, so if I figure out what the vertical final velocity is, then I can figure out what time is. If I know what time is to hit the ground, then I know the time that it's going to travel horizontally too. So both of these times will be known. And then if I know time horizontally, then I can figure out what xf is horizontally as well. Where did it land horizontally? And I can actually have my choice of equations now. There's this one, and there's this one right here. All of those will allow me to find xf horizontally because now I'll have all of this information. I'll have a time, and that will allow me to use all of these. Cool. I'm just going to grab one of these, let's say this one, and that's the one I'm going to use. Alright, so a little bit of a recap here. What we started with was how do we choose what variables go where? How do we fill in that information? The second thing we looked at is how can I take that information and set up what am I going to do? How am I going to solve this problem? I figured out that I need to find xf horizontally, but in order to do that, I first needed to know time, and in order to do that, I first probably needed to find the final velocity. Now, this is specific for this problem, so this may not be the case for every problem we look at. So with every problem, we have to examine what do we know, what do we don't know, and what steps will allow us to answer those question marks. So we'll do some practicing of this in class as well, and then what we're going to do is use a simulator to actually check out and see, does our equations work? Is the plan that we came up with going to work for the problems that we have? All right.